Brown dwarf. Imagine a star trying to be born and failing. Deep inside a giant cloud of gas, gravity pulls matter together. The temperature rises, the pressure builds. Everything looks ready for a new star to ignite. Then it stops. The object isn't massive enough to start full nuclear fusion. It never becomes a true star. Instead, it becomes something astronomers call a brown dwarf. Too large to be a planet, too small to be a star. A cosmic failure that can spend billions of years drifting through the darkness. Red dwarf. If you could choose one type of star to survive the end of the universe, this would be your best bet. Red dwarfs are the smallest true stars. They burn their fuel incredibly slowly, sipping energy instead of wasting it. While stars like our Sun live for billions of years, some red dwarfs may survive for trillions. That means many of the red dwarfs shining today could outlive almost everything else in the cosmos. They aren't the brightest stars, they aren't the largest, but they are the ultimate survivors. Yellow dwarf. This is the type of star most people already know, because you're living next to one right now. The Sun is a yellow dwarf. It may look enormous from Earth, but compared to many stars in the universe, it's surprisingly average. Every second, the Sun converts millions of tons of hydrogen into pure energy. That energy powers weather, oceans, plants, and nearly every form of life on Earth. Without this ordinary-looking star, none of us would exist. Blue star. Some stars are born with far more mass than the Sun. And with that mass comes incredible power. Blue stars are among the hottest stars in the universe. Their surfaces can be tens of thousands of degrees hotter than our Sun. They shine with a brilliant blue-white light and release enormous amounts of radiation. But their power comes at a cost. These stars burn through their fuel at an astonishing rate. While smaller stars may live for billions or even trillions of years, some blue stars survive only a few million. They live fast, and they die young. Red giant. Even stars grow old. One day, a star like our Sun will begin running out of hydrogen fuel. As its core changes, its outer layers start expanding outward. The star grows larger and larger and larger. Eventually, it becomes a red giant. Mercury would disappear, Venus would disappear, and Earth could be swallowed as well. A once stable star transforms into a colossal, aging giant nearing the end of its life. Blue giants are what happen when immense stars become even more extreme. These stars can be dozens of times more massive than the Sun. Their temperatures are so intense that they flood space with radiation. They shine hundreds of thousands of times brighter than our home star. From a great distance, they can completely outshine nearby stars. Yet despite all their power, their lives remain incredibly short. The brighter the flame burns, the faster it fades. Red supergiant. Now we're entering the realm of monsters. Red supergiants are among the largest stars ever discovered. If one replaced the Sun, its outer layers could stretch beyond the orbit of Mars. Some might even reach Jupiter. These stars contain enough material to create entire solar systems worth of matter. Yet despite their enormous size, they are unstable. Their final moments are approaching, and when they die, the entire galaxy notices. Hypergiants are stars pushed almost beyond the limits of nature itself. They are so massive and luminous that they constantly lose material into space. Some eject giant shells of gas larger than entire solar systems. Others shine millions of times brighter than the Sun. If a hypergiant appeared where the Sun is today, Earth wouldn't simply burn. The planet would be completely destroyed. These stars are among the most powerful objects ever formed by nature, but they are also among the most short-lived. Wolf-Rayet Star. Imagine a star so violent that it begins tearing itself apart. That's a Wolf-Rayet star. powerful stellar winds blast material away at millions of kilometers per hour. The star gradually strips off its own outer layers, exposing its incredibly hot core. These are some of the hottest stars known. Some shine so intensely that they can influence entire regions of their galaxy. Astronomers often view Wolf-Rayet stars as ticking cosmic time bombs, because many are only moments away from a spectacular ending. Neutron Star. Then the explosion happens. A massive star dies in a supernova. For a brief moment, it can outshine an entire galaxy. When the explosion ends, something extraordinary remains. A neutron star. An object with more mass than the sun, compressed into a sphere only about the size of a city. A single teaspoon of neutron star material would weigh billions of tons on Earth. Some spin hundreds of times every second. Others fire beams of energy across the universe like giant cosmic lighthouses. These are among the strangest objects ever. But sometimes, even a neutron star isn't the end. If a dying star is massive enough, gravity wins completely. The collapse never stops, space bends, light cannot escape, and a black hole is born. But that's a story for another video.